Good evening, guys. David De Los Reyes. My topic tonight is integration by using partial fraction. There are 4 variations in integration using partial fraction. Let us discuss variation number 1. Variation number 1. Integration by partial fraction. Variation number 1, guys. Linear factors only. If the given form involves only linear factors, let us bring out the form. f1 of x over f2 of x equal to capital letter A, excuse me, over x minus a plus capital letter B all over x minus small b. These are linear factors. Okay? And they are not equal. So if the form is something like this, it falls under linear factors only. Meaning the resulting denominators will be a linear factors. Excuse me. X minus a, x minus b. Linear. Okay? There is a condition for this one. F1x should be of lower degree than F2x. Meaning, the given numerator should be of a lower degree than the denominator. Okay? And F2x, the equivalent of this in terms of linear factors is quantity x minus a, quantity x minus b. Okay, linear factors. For the meantime, we are only discussing integration using partial fraction if f2x, meaning the given denominator, is of the form linear factors only. Linear factors. Linear factors which are not equal. Because if they are equal, that's a different story. That will be our next topic. Okay? Let's proceed with the example. I will just give example number 1. It seems from my previous lessons that my examples are too much. Maybe you could not catch up. I don't know. Maybe it's too many already. Maybe it's too boring to follow the lecture. So I will just give one example for tonight, and let's see what happens. If you could follow it without any boring times, you know. Okay? Let's bring out example number 1 for tonight, involving linear factors only. Find the integral of 2 dx all over x squared plus x minus 2. If you try to look at it, the given denominator is a quadratic equation. If it is a quadratic equation, there should be a linear equivalent as a function of two factors, two linear factors. It should be of the form x minus a, x minus b. Because if we multiply x times x, that's x squared. Okay? But what is a and what is b? Right? Okay, let's bring out the solution. X squared plus x minus 2. Okay? Use our knowledge of factoring. X squared could be x times x. Okay? Let's try to check the value of the middle term. If this is plus 2 and this is minus 1, okay? Plus 2 times minus 1 is minus 2. It satisfies this one. But will it satisfy the middle term? Because our middle term is the pure linear term. It's simply a coefficient and an x term, okay? Let's try to verify if the value plus 2 and minus 1 here will give us the correct middle term. The middle term is 2x minus x. X times minus 1 is minus x. Okay, I'll show you this one. This one here is 2x. Okay? This one here is minus x. Okay? If we try to combine, this is equal to x. And this is, luckily, it is exactly the same as the given problem. So, actually, x squared plus x minus 2 can be factored out into its linear form, linear equivalent, as the product of x plus 2 and x minus 1. So this x minus a and x minus b, we will just place it back, x plus 2, and this is x minus 1. Okay? We will rewrite the original problem, okay? The integral of 2 over x squared plus x minus 2, this is multiplied by dx, equal to the integral, okay, of the right hand side multiplied by dx. As simple as that one. We are now bringing out an equivalent in terms of linear factors as a partial fraction, two partial fractions. It should be an a over x plus 2 plus capital letter B over x minus 1 close quantity dx. Okay? Meaning, this given left hand side will be the equivalent of this one, but what is A and what is B? That's the problem there. So actually, we are resolving the given problem into its equivalent as a function of two partial fractions. Partial fraction number 1 is a over x plus 2. Partial fraction number 2 is b over x minus 1 close quantity dx. Okay? Okay, I will remove this one again so you will not be misled into thinking of something. Okay? If we try to simplify this one, actually this one is the product of x plus 2 x minus 1. Okay? So, to remove the denominator, okay, we will multiply all the terms by x plus 2 times x minus 1. Right? All the terms, left hand side, right hand side. 2 all over this times x plus 2 x minus 1. Actually, the given left hand side is actually, it's the same as this one. The product of x plus 2, because we solved it, times x minus 1, right? So the left hand side multiplied by this quantity here, x plus 2 cancel with this, x minus 1 cancel with this. What will remain on the left hand side is just simply 2, equal to a over x plus 2 times this quantity here, x plus 2 cancel with this. So what will remain will be a times x minus 1. This is a times the quantity x minus 1. Second part, b over x minus 1, okay, times quantity x plus 2 times x minus 1. This x minus 1 cancel with this. So what will come out on the second term will be b times x plus 2. Right? Simplifying, 2 will be equal to ex plus bx minus a plus 2b. This is ex, this is bx. I write it very near each other. A times minus 1 is minus a. B times 2 is actually 2b. Okay? So this is now the resulting equation. Okay? Let's try to compute now for the value of a and b. And to do that, we will equate coefficient of like terms. Okay? Let's start with x to the first power. Left hand side, there is no x term, right? So this is 0. Right hand side, it will be a plus b. We got 2. we got two terms with an x, right? So we will just take a plus b. This is a plus b. Or a is equal to negative b, equation number 1. Okay? Equating again coefficient of like terms, x to the 0, meaning all pure constants. The pure constant on the left is 2. The pure constant on the right is it is minus a plus 2b. This is minus a plus 2b, equation number 2. So we are now given two linear equations involving two unknowns. That's plain algebra. Okay. We will substitute a equal to negative b to equation number 2. 2 now will be equal to negative. We'll paring this. Negative open quantity minus b. Okay? Because a is minus b. Plus 2b. This minus minus, this is plus b, plus 2b is 3b equal to 2, or b equal to 2/3. b is equal to 2/3, and since a is equal to b preceded by negative sign, so a will be negative 2/3. Okay? We are not yet integrating. We are just resolving the given denominator as a function of two linear factors. And luckily, we have solved already for the value of a and b, okay, for it to be the linear equivalent on the right hand side. Therefore, the integral of 2 dx over x squared plus x minus 2 equal to the integral. This is a over x plus 2. This is plus b over x minus 1, close quantity dx. Minus 2/3 is actually a. 2/3 is actually b. So we just substitute it, guys. Okay? We are not yet integrating. Therefore, this is minus 2/3, right? So we bring it out, minus 2/3, the integral of dx over x plus 2. Pure constant, we bring it out, 2/3. Guys? The integral of dx over x minus 1. This is only the integration portion. So actually, majority of the solution is algebra before we could proceed with the integration. Okay? If we now try to look out the two resulting integration, I think this falls under natural logarithm. Natural logarithm. This is under the integral of du over u, and the answer should be natural logarithm of u plus c. For the first one, the value of u, the value of the term on the denominator is x plus 2. du is equal to dx plus 0, or du is just simply dx. It is exact. Second term, the value of u on the denominator again. This u is different from this u, okay? We are talking of this term here. U is x minus 1. du is equal to dx minus 0, or du is just simply dx, dx, exact. So this falls under natural logarithm. This falls under natural logarithm. And this is the solution. Take the natural logarithm of u for both terms, plus c, that's the answer. So the final answer will be negative 2/3. This falls under natural logarithm of quantity x plus 2. Plus 2/3, okay, natural logarithm of x minus 1 plus c. Common factor 2/3, okay? Common factor is 2/3. I will bring it here. 2/3. The first one, we will take the plus side. The natural logarithm of x minus 1. This is negative, right? Minus the natural logarithm of x plus 2 plus c. And this should be equal to 2/3. Under the laws of logarithm, the logarithm of the difference is just the logarithm of a quotient. It should be the natural logarithm of x minus 1 over x plus 2 plus c. This is the final answer. The logarithm of a difference is a logarithm of a quotient. The common coefficient is 2/3. Under one natural logarithm sign, quantity x minus 1 over x plus 2, that's it. Eye contact, guys. That's integration by using partial fraction under variation if the given denominator contains only linear factor or linear factors. Okay? So as you can see, to bring out the integration to this, we must have to solve for A and to solve for B. Okay? By using our knowledge of algebra and by using the so-called equating coefficient of like terms to bring out the two linear equations so that we could solve for A and for the value of B. Okay, guys? As simple as that one. Integration by using partial fractions. The denominator involves only linear factors. They are not repeated. Two different linear factors. That's integration by using partial fractions. Okay, guys? See you.